Hello and welcome to Solutions Video 3. We'll be talking about how solutions behave, how to predict whether or not we're going to make a solution. Make sure you're taking notes because there's some key ideas in this video. First of all, I want to talk about the factors that affect whether or not a solution will be created if a solute dissolves in a solution. The first is temperature. Temperature is a huge factor in solubility. Generally, as temperature increases in a solution, the solubility of a solid is going to increase. More sugar dissolves in hot tea than in iced tea. Gases are the opposite. As you increase the temperature of a solution, gas solubility decreases. Think about a soda. If you leave it in your car for just a little while, all the gas that's been placed into that solution tends to escape the solution rapidly. Second is the nature of the solute and solvent. We need like natures for dissolving to happen. Polar solvents dissolve polar solutes. Non-polar solvents dissolve non-polar solutes. And you'll hear the phrase a lot, like dissolves like. So if you know the properties of the solute and the solvent, you know whether or not you are likely to make a solution. And here's just a little riddle, for lack of a better word. Benzene does not dissolve in water, but it does dissolve in carbon tetrachloride. Glucose does not dissolve in benzene, but it does dissolve in milk. Water does not dissolve in carbon tetrachloride, but it does dissolve in milk. So just looking at that, water does dissolve in milk. Well, we know water's big P polar, and we know milk must be then big P polar. Water does not, or milk doesn't dissolve in, or sorry, water doesn't dissolve in carbon tetrachloride, so that's going to be nonpolar. And then it means the same for benzene. And then we said glucose does dissolve in milk, so glucose is polar. You get the idea, though. This riddle leads you in the right direction. If understanding water is the linchpin here, and knowing water is polar, the rest of it you can figure out. The third pressure that affects whether or not something can dissolve is pressure, and this applies only to gases. You're going to need an increased pressure in order to put more and more of a gaseous solute into a solvent. And that's how soda is made. Under great pressure, carbon dioxide is placed into solution, and then it's bottled and sent to you under pressure. You have to depressurize it to consume it, which then allows that gas to escape. So we've changed a factor in order to get gas dissolved in water. The second big idea here is the rate of solubility, how fast something dissolves. And again, temperature is a huge factor. The more kinetic energy a solution has, the more collisions that'll take place between the particles, and the more that solute will dissolve. More kinetic energy means more possibility of dissolving whatever that solute may be. The second is agitation, stirring. More contact with the surface of the solute and the solvent, the solution dissolves faster, or the solute dissolves faster. And third, the solute surface area. Smaller particles offer a greater surface area. Okay, so the greater surface area you have of your solute, the more or the faster you dissolve that solute. A couple things about solutions, just some definitions here. Saturated solutions, again, contain the maximum amount of solute given at a constant pressure, or constant temperature, pardon me. An unsaturated solution contains less solute than a saturated solution. In other words, more solute could be dissolved. And third is supersaturated solutions. Supersaturated solutions are solutions that contain more solute than a solution should be able to hold at a constant temperature. And these are very delicate beings. You have to create them on purpose. They're created by heating a solution, saturating it, and then slowly cooling it. When you're cooling it, you're basically oversaturating it because you're reducing the temperature at which that solute dissolves. However, the solution may persist until you give it some sort of a reason to crystallize. You can drop a crystal in or agitate the solution by thumping a glass jar. Very simple things can set it off. You've seen supersaturated solutions if you've seen those little squishy body warming devices with a little metal clip inside that you pop to get it to solidify and heat up. That's a supersaturated solution of sodium acetate. We will actually make one in class and play with it. And finally, let's look at a supersaturated solution here. This is an interesting video. Let's see if it plays. Well, it's not going to play. But what you would see here is that a seed crystal is placed into the solution by a little pair of tweezers. And slowly, but certainly, the solute, or the solution crystallizes. When we seem to have lost the functionality. Nevertheless, we'll show you this actually happen in class. Essentially what happens is the crystals are, once you give them one reason to line up and form a crystalline structure, the entire thing will rather rapidly crystallize into a solid. We'll start with solubility graphing and solubility curves on the next video. Please make sure you come to class with questions so we can help you through them. Big key ideas with the factors that affect solubility and the factors that affect the rate of solubility. So make sure you're very clear on those two different things. We'll see you on the next one.